That is 29. All right, now, with composition, you can reverse the order. Like here, who got 1 first here? Who got 1 first? G got the 1 first, and then that answer went through F. But couldn't we send the 1 through F first? Right, we could. So what does that notation look like? Well, that's part B. So look at part B. I'm going to leave this up here. Yeah, I'll leave it. Maybe I won't. I don't want to erase that, but then I don't want to erase this. Let me erase this part. Okay, so if I do part B, for part B, I'm going to do G of F of 1. Okay, I'm going to just write it down. First of all, what does that mean? It means G, but inside of G goes F, and inside of F goes 1. Right? G is going to be getting whatever happens here. So 1 goes into F first, and then G is on the outside. So what is F of 1? What happens if you plug 1 into F? Let me get this. So we're going to have G still, right? We haven't done anything with G, but inside this piece, F of 1, what happens when you plug 1 in there? You get 1 squared times 2, so negative 1, right? You get negative 1 there. So that becomes negative 1. But now that gets plugged into G. And what happens when you plug that into G? It's 4 times negative 1, which is negative 4. See, we got 2 different answers, didn't we? When we plugged it in this way, it got 29. And when we plugged it in that way, we got negative 4. So the picture of this one is you have 1, right? Goes here, and then that goes here. Let's see, who got it first here? Who got the 1 first? F got the 1 first. And that went through and came out as a negative 1. That negative 1 then went through G, right? And then comes out as negative 4. Now, a lot of times when this is taught at this level in college algebra, and maybe in high school you may have seen this, a lot of teachers like to call this fog, or if you change the order, they call it Goff, which is cute, but I don't want you to limit yourself that way because there's nothing that says that when you do composition, it has to be fog or Goff. It can be part C. It can be FOF. So what does FOF, what does F of negative 2 mean? It means negative 2 is going to go into what first? F. That's going to give us an answer, right? And then that answer is going to go into F again. So it's like you're sending the car through the car wash twice. Same car wash, right? So that's part C. Let's do that one. So for part C, what is F of X? Well, that means F is going to be on the outside, and then inside is F of X again.
So we do the operation twice.
Do it twice. Oh, sorry, I wanted F of negative 2. Sorry, not of X. Negative 2, negative 2. All right, so what happens when you plug negative 2 into that? Let's go ahead and do that. I'm going to do F is still on the outside. What I'm doing right now is this piece right here. I'm going to actually write out what it is. That's 2 times negative 2 squared minus 3, right? That's what that is. So negative 2 squared is 4, right? 4 times 2 is 8. And then minus 3 is 5, right? So we get F of 5. We still need to figure out what F of 5 is. And what happens when you plug in 5 into that function? Well, you go 2 times 5 squared minus 3. And when you square 5, you get 25. Multiply by 2, you get 50. Subtract 3, you get 47. Is that clear? And of course, you could do G of G, right? You could do send a number through G and then send that answer back through G, right? What's your question?
How many times can I do this recursively? Like, how many times can I say?
There's no limit to how many times you can do it. In fact, I was going to skip their D. I'm going to have my own D, or I'm going to make up my own E. What would this be? What would f of g of f of 1 be? Okay. So we have to understand what this notation means, right? So if you look at this notation here, what function is on the outside? What function is the last function to get the x, or to get the input? F, right? So this f, and then inside of that is g, right? So it's almost read from like left to right. So the way this would work is first I would do this, right? F, but inside of that goes what? G, but inside of that goes what? G again, but what goes inside of that? F, but what goes inside of that? 1. Do you understand? Does it kind of make sense? Now, picture-wise, let's look at the picture first. I think it's worth us seeing the picture of what's happening. So we have this, we have 1, right? And 1's going to go through what first? F, right? That's going to give us an answer, right? F of 1, whatever that is. Then that answer is going to go through what? G. And then that answer is going to go through G again, and then that answer is going to go through F. And we're going to have a final answer at the end, right? All right, so just take these one at a time. What's F of 1? Figure out, oh, F of 1. We've got to figure out what that is. What happens when you plug 1 into F? You get -1. So you get F of G of -1. You have to have the same number of parentheses going this way as this way. So I have 3 of them this way, 3 of them this way. All right, what's G of -1? -4, right? That's what happens when you plug -1 in there. So this is F of G of, and then this part became -4. 2 parentheses this time. Okay, so that went here. Yeah. And now what's G of -4? When you plug -4 into G, you get -16. And now you got to plug -16 into F. Okay. What's -16 squared? Is it 293? No, 296. 256 times 2, and then subtract 3. Okay? All right, does this make sense? The idea of composition, does it make sense? Now, we have to continue with this concept. All I've done right now is tried to show you what composition looks like when you plug in a general, like a number, right? I've been plugging numbers in. But is there a way that we can compose these functions without plugging in a number? Like if I ask you to add these 2 functions together, could you add them? Could you add those? Yeah, you just do that plus that, right? That'd be your answer. If I told you to subtract, you do that, subtract that. If I told you to multiply, you do that times this, and you would have to distribute through. If I told you to divide, you could divide. But can you find the composition of this function without me actually giving you a specific number? That's what we're about to do. So I'm going to give you a new set of functions. We're going to use this example here. So I'm giving you brand new functions. They're x squared plus 3x plus 1, minus 1. And the other function is 2x plus 3. So you have 2 brand new functions, and here's what I'd like for us to find. First of all, what's f of g? See, but I'm not going to give you a number. I'm just going to say of x. What is f of g of x? What do you get when you compose these functions together? First thing I'll do is write down what the definition of this means. This means f, and inside of that goes g. Now, in the past, the problems we just did, this was a number, wasn't it? Then you just took that number and you plugged it in here and you got a new number, right? But see, I'm not giving you a number anymore. So what you're going to do is you're just going to replace g of x with what it is, okay? You're going to replace g of x with, well, what is g of x? 2x plus 3, right? That's exactly what g of x is. And now the very important part. What happens when you plug in 2x plus 3 into f? It goes into this function, and everywhere you see an x, right? Everywhere you see an x, you need to replace it with 2x plus 3. So that needs to become a 2x plus 3, and that needs to become a 2x plus 3. So I'm going to write this down. 2x plus 3, what? Squared. I need it in parentheses, squared. Okay, that's the first part. Plus 3 times 2x plus 3. Should I put that in parentheses? Yes, because that 3 multiplies, right? This is like x squared plus 3x, right? Minus 1. Do y'all see it all? All right, now we're not done. We're going to expand that. We're going to clean this up. So when I square that, I have to do 2x plus 3 times itself. And then on this, I have to distribute my 3 through. So plus 6x plus 9 minus 1. So I went ahead and did my distribution here. I still need to actually do this, right? So FOIL that out. So when I FOIL this, 4x squared, you're going to wind up getting plus 12x plus 9, then plus 6x plus 9 minus 1. I did this in my head, kind of. I did that and then collected like terms. So this step, I kind of skipped a little step there. Collect like terms, 4x squared plus 18x plus, let's see, plus 17. Right, 9 plus 9 is 18, take away 1. There we go. Nope, that's it. That's your answer. Now, what does this new function do?
Quadratic.
It's a quadratic, but let's see, what does it do? So let me ask you this. What is f of g of 0? Okay, let's do what we did on the previous example, all right? Do it as a picture. Who gets 0 first? G, right? So what happens when you plug 0 into G? What do you get? 0 into here, you get 3. Everyone see that? You get 3. And then what happens when you plug 3 into F? So plug 3 into this. What's 3 squared? 9 plus, what's 3 times 3? 9. So what's 9 plus 9? 18, take away 1, you get 17, right? You see that? Right? f of g of 0 is 17. But do you see that this formula we came up with would have done all of that for us in one step? See, if we're saying that f of g of x, right, of any number is always going to be this answer. So if I ask you now to plug 0 into this, what do you get? 17. It's doing all of that for us. Do you see that? It's doing the actual two functions together and creating a brand new function. This is called the composition of those two functions. All right? Questions? All right. So if you feel like you get it, why don't you do part B? So I want you to do part B right now.
Okay.
So Part B says find g of f of x. All right? So you should have an answer that is a function at the end. See if you can figure it out. I'll leave everything up there. This one's much easier. I'll give you another minute. Are y'all burned out? Are y'all all right? Is it the weather? Y'all are all sleepy and okay? Still got all of November to go here. A little bit of December. Okay, here's what we should have. You rewrite this, it's G, inside of that goes F. Right? It's the opposite this time. Now, I'm going to leave G alone, and now inside of that, I'm going to replace the f of x with what it is, right? X squared plus 3x minus 1. And now, I'm going to take G, and everywhere I see x, right, I replace that x with the x squared plus 3x minus 1. So we should have 2. And then all of that, right? In parentheses, x squared plus 3x minus 1. But then, am I done? Still need what? Plus 3, right? Plus 3. So this is the g function with the x replaced with that blue thing. And now distribute the 2 through. You should get 2x squared plus 6x minus 2, but we still have the plus 3. And now final version here. Okay. Show of hands. How many of you got that? Okay, great. All right, so composition so far okay? So far? All right, now when it comes to composition, we have to be extremely careful with domains. With domains. Now, look at these two functions. This function right here is a polynomial, right? Yes, we graphed. It's actually quadratic, but quadratics are polynomials. What's the domain of any polynomial? All real numbers. This is a line, which is still a polynomial. What's the domain of that? All real numbers. When both functions have domains of all real numbers, you never have any trouble with the domain of the composition function. You can see from over here, this is also a polynomial, right? It has no problems. But you have to pay attention. If one of these has a problem with its domain, you have to pay attention to that when you're doing composition. I'm going to show you an example right here. This is one of the most confusing concepts when it comes to composition, is how domains are impacted when you do composition. So I'm going to try and show this to you visually first, and then we'll try and come up with a systematic approach to it. So 2 new functions. The first function is f of x equals 1 over x plus 2. And the second function is g of x equals 4 over x minus 1. All right, so a real quick glance at that. Does f have any domain problems? Yes, what can you not plug into this? -2, right? You'll get division by 0. Does this have any domain problems? -1, right? I'm sorry, +1. Y'all agree? So right now, f, you can't plug in -2. G, you can't plug in 1. That does not mean we throw those two numbers out yet, okay? Pay attention. I want us to find the domain of f of g of x. I'm going to try and show this to you visually first, right? Visually. Hey, you got, this is important. I just don't want you to sleep through this, all right? When I was in high school, I had a teacher. His name was Colonel Reck. He was in World War II, no, Korean War, I don't remember. Anyway, he had this huge-ass dictionary encyclopedia. I mean, I'm serious. It was like this thick. It was freaking heavy. And if someone would fall asleep, he would tell everyone to be quiet, right? And he would come up to you, and you'd be asleep on your desk or something, and he would get this thing, and he'd slam it on the desk right in front of you. Oh my gosh. He only had to do that once or twice, and that was it, because that would wake you up. Oh, it's hilarious. Or he would get, they were chalkboards, right? So he would get the eraser, like if you were asleep, and he would like get people to clear out, and he'd throw the eraser at you, right? So this one time, this guy was asleep, and Colonel Reck grabs his eraser, and he's going to throw it. And right as he threw it, the guy woke up, and he grabbed his binder and deflected it. And the guy behind him was just sitting there and just boom, right in his face, a big old cloud of chalk dust everywhere. He's an innocent bystander. But he used to, when he would hand out our test, he would hand them out, he would give them to us in the order that you know, highest to lowest on the test. Highest grade in the class. And then if you were doing well, he would make you stand in the corner with a hat on. He called it the Space Cadet Corps, right? These were so I went to a private school, so it was like they could humiliate you, and it was okay. But that was motivation. Trust me, it was motivation to study, to not be part of that Space Cadet Corps. Anyway, Colonel Reck, great guy. All right, so domain. I'm going to try and do this visually. Who gets the number first? G gets it first, right? You have to understand that, right? G gets x first. So whatever x is, it's going to go into G first. Okay, so what do I have to make sure can't happen then? What can't be here? Well, where does G have a problem? At 1, right? So right now, because G's going to get x first, I know that x cannot be equal to 1, right? For sure, or else G will have a problem with that, won't it? Now, once x goes into G, when x goes into G, doesn't it turn into 4 over x minus 1? That's what happens when x goes in, doesn't it? Whatever it is, it's 4 over x minus 1. Follow? Now, that goes to what function? F. And what can f not handle? F can't handle -2. So this is the part. This is the part that's tricky. I'm not saying that x can't be -2. I'm saying that what can't be -2? This can't be -2. See, if you send a number through, right, and it comes out over here, if it were to come out, like take some number, I'm not sure what it is, but if it comes out over here as -2, then what the hell's f going to do with that? It's not going to be able to, right? So this is the thing that comes out. What I need to make sure here is that 4 over x minus 1, right, cannot be equal to -2, right? That's what I want to make sure, is that this doesn't happen. Right? Well, not canceled. This would cause a problem, right? If this number right here was -2, then the next step couldn't happen because I couldn't plug -2 into f, right? Because then it would be division by 0. So I need to figure this out, right? If I want to make sure this doesn't happen, let's figure out where it does happen. So solve that equation real quick. This is an equation, not an inequality. So let's multiply both sides by x plus 1, or x minus 1. Cancel, cancel. We get 4 equals over here. Distribute. Negative 2x plus 2. Subtract 2 on both sides. Divide by negative 2. Am I doing that too quick? Solving this equation? X is negative 1. Do y'all agree? If I plug in negative 1 right here, what is negative 1 take away 1? Negative 2. What's 4 divided by negative 2? Negative 2. And I don't want that to happen, right? So I've got to make sure that x is not negative 1.
If you're dividing by 2, wouldn't that have a plus 1 next to it?
If I divide by 2, what?
Where the... Oh, you subtracted 2. Oh, okay.
Yeah, I subtracted 2 on both sides here to get that. And then I divided both sides by negative 2. Good? So x can't be negative 1 either. So the question was, what is the domain of the composition? The domain of this composition is that, first of all, we can't plug 1 into this. We plug in 1, then g is going to have a problem, right? But then you also can't plug in negative 1, because if you plug in negative 1, this is going to turn out to be negative 2, and then f has a problem. See, it's a little more complicated than just looking at these two. Can I plug in negative 2? Can I plug, negative 2 is a problem here, right? But can I plug negative 2 in here? Yes. Because when negative 2 goes through here, it does not come out as negative 2. It's a little tricky, all right? So I need the final answer. Yes?
Can you plug in anything?
Other than those two numbers. So what is the domain? I need to answer this question. What is the domain of this composition? Let's draw a number line real quick. Here's 1. Here's negative 1. I can't have that. I can't have that. These two numbers can't be there, right? And I can have everything over here, everything in between, everything over here. Anything else works. So the domain is negative infinity all the way to negative 1. Don't include negative 1. Union, everything between negative 1 to positive 1. Don't include those. Union, everything from 1 on to forever. All right? You think you get it? Okay, try it the other way around then. Let's see if you can do it. Flip it over, g of f. The domain changes. Okay, so I want you to see, I'll leave this kind of on the board, but I want to do this problem. I want you to find the domain of g of f of x. Okay, I want you to try and do that. Find the domain of g of f of x. I suggest you draw a picture, try and understand what's happening, right? I'll give you a few minutes. I'll be back. Are y'all getting a different answer? Should. All right, so I want a g of f of x, right? Domain. Who gets x first? F does. Okay, so what can I definitely not plug in? -2. Can't plug in -2 because, oh, sorry, I forgot to put f. F gets it first. I can't plug -2 in here. So right away I know x cannot be, right, -2. All right, now, when f gets x, f is going to spit out 1 over x plus 2, right? That's what f does. And then that's going to go and get sent through g. Now, what can g not handle? 1, right? I can't plug. So what I need to make sure is that this doesn't turn into a 1, right? If this is a 1, I'm in trouble. So that means I need to figure out, let me write it just the way I wrote it over here. I'm going to say, all right, well, I know that g is about to get this, and g can't handle a 1 being plugged in. So I need to make sure that that 1 over x plus 2, right, is not 1, or else g's in trouble. But I can solve that or figure that out by figuring out where it is 1, right? Just solve the equation. Multiply both sides by x plus 2. And subtract 1 on both sides. Or, sorry, subtract 2 on both sides, you get -1. So I don't want this, right? I don't want that. So x can't be -1 either. This would be okay if you just give me this. That would be okay. You don't have to give me the interval, because I trust at this point you could all draw me that interval. How do you feel? Feel like you understand that? Okay, how about this then? I'm tempted to give you a quiz, but I'm not going to yet. So let's keep the same problems up here, okay? I want you to find the domain of f of x. F of f of x.